Alright, welcome to the last unit we are doing. I'm on page 1 of the unit. Alright, so we're going to be using the derivatives and getting some information out of them and just applying a little bit of what they can do. Alright, so you have a function at the top of page 1, and we can look at that graph. We can figure out what it looks like by using the first and second derivative. Yes, you can take a second derivative after you take it first, so you just take one and then do it again. So when you're doing these are not going to be the complicated ones where you do a chain rule and the product rule. We're just going to be doing the power rule where you multiply the exponent with the coefficient and then subtract by 1. So 1/3 times 3, so 1x squared plus 8x plus 15. Alright, so anytime you take a derivative, it goes down by a power of 1. So the degree on here was 3. The first derivative is a 2. The next derivative, when we do a second derivative, will be just a 1. Alright, so now we're going to get our information by setting the derivative equal to 0 and solve for x. So that includes a little bit of factoring. So x squared plus 8x plus 15. Set it equal to 0. These are going to be factorable and stuff, so two numbers that multiply to 15 add up to 8. We're doing some nicer numbers here. And plus 5, doesn't matter which one's first. X equals -3 and x equals -5. So those are some important points for us. Alright, so number over here on the number line, I would take it and set what? So kind of put them in order where they would be on the number line. So 0 would be over on one part, and I'm putting it over the side because I have two negative numbers. So -1, -2, -3, -4, -5. Alright, so now I'm kind of taking the information and I'm going to pick numbers in between these or to the side of these. So I'm going to pick -4, and I'm just trying to figure out, is my answer positive or negative? So you can write down the number you want, or you can just write the positive or negative sign. So over to the left, 0 is always nice to plug in. So I'm going to plug in, sorry, this is the right, 0 on the side of -3. And I'm going to plug in -4, and I'm going to plug in -6. Now, of course, you can do this with your calculator, that's fine. If I plugged in 0, 0 would give me 15, so that would be a positive answer. If I plugged in -4, would it have 16 plus what? -32 plus 15, which would end up being -1. So that's a negative. And what? I'll plug in -6, so I'll get 36. And I'm plugging it into this derivative. -48 plus 15, so that would be what? 51, so that would be 3. Oops. 3. So that's a positive. Alright, so what this means is my values go from, the y values go from a positive, hit the 0, and then go to negative. So this means the graph goes increasing and then decreasing. So we are looking at the graph, values going up to negative and then going down. Now this one is the reverse. They are decreasing because this, we know this is going down, and hitting -3 and then going back up. So why do I know it's doing these things? Why do I know it's going that at -3? Well, let's backtrack. The idea is, remember, a derivative is that it's the slope of a tangent line at the graph at that point. So at -3, I know my slope is going to be 0 because I set it equal to 0. Okay, so that means it's going to bottom out and have a tangent line of 0 slope. Okay, so maximums, the y values go like this. They go up and then down. You reach a peak. And then for a minimum, the y values decrease and then increase. We did this a long time ago, back on unit 1 and 2, where you found the increasing and decreasing. So the maximum is going to be at -5, and the minimum is going to be at -3. Alright, so now when I have to do the second derivative, I go to the first derivative and take the value of that. So it's going to be 2x plus 8. Do that derivative. Set the second derivative equals 0. The 0 is the second derivative, give you inflection points, which means they tell you is it concave up or concave down. So I set 2x plus 8 equal to 0. I get x equals -4. And see what's going on the other side of it. Okay, to the right is 0, to the left is -5. Plug it in. 2 times -5 plus 8, I get a -2. 0 here is a positive 8, so positive. Alright, so when it changes from positive to negative, concavity, like it says, concave up or concave down. So a negative for an inflection point. Concave down means it's going to be going like this. Concavity negative means it's upside down. So everything is going towards the negatives. When it's concave up, you're looking at it going like this. Alright, so when we do this, the inflection point at -4 for the x values, the graph changes concavity, meaning it's going to switch from the original graph. It's going to switch like this and say, okay, this is where it's negative and this is where it's positive. Alright, so we need to use the following information to make our graph. When the derivative is negative, the function is increasing. When it's positive, it's decreasing. Alright, so what do we got here? Y equals... what do we got? X to the 3rd plus 4x squared plus 15x minus 2. Alright, so again, I'm looking for some of these values. Wait, what? Something seems a little weird. Alright, so I'll get the graph on there and post it and show you what's going to look like, and I'll highlight some of the stuff. Get these notes done and do kind of the same thing on pages 2 and 3 for tomorrow. Do the first derivative, set it equal to 0, and then we'll get the information, figure out the maximums or mins, pick numbers on either side of it, and we'll go through, get the graphs done from there. So do a second derivative, get the inflection point. Same thing on page 3. So just work again, still working with derivatives and going through first and second and doing some solving. So talk to you later. Bye.